Hi everyone, we're going to continue on with what we had started yesterday, looking at moments. Now, if you remember what we had talked about then, we had said that there were two basic equations that we are going to be using regarding moments. The first one is that in a situation that's static, meaning that it's not accelerating or that it's stationary, that the sum, remember this is the symbol for sum, of the moments around any point is going to equal 0. And when we say we're going to add up these moments, it's important for us to know how to calculate a moment in the first place. So a moment is a force times a distance from the point we're measuring. Now remember, it is absolutely critical that when we measure the distance, the line that we're measuring is perpendicular to the force. If it's not, everything's going to be wrong. Okay? So what we're going to do today is I'm going to go through and do two example problems. And then you're going to have two similar practice problems, and the video will stop and you guys can go ahead and do those and type the answers in. And we're going to grade you on that, all right? So let's look at the first problem here. What I have is basically a lever. And if we think back to early in the year, I've got my fulcrum here, I've got a downward force, and I'm going to need to apply an upward force out here, I'll make it black, to hold it up. So this is my force of resistance, is my 80 pounds. Then my force of effort is out here at this end. Think back, what kind of lever would this be? Our resistance closer to the fulcrum, our effort further away. Hoping you all are saying second class lever, because it is a second class lever. So let's look at how we'd go about solving this. So first, I want to kind of color code some of these things. I'm going to make my fulcrum red, and I'm just going to do this so you can see where each individual part of the equation is coming from. I'm going to make my downward force here blue, and let's make our upward force green. All right, let's switch back real quick. All right, so we're going to start with our basic equation here. We're going to say that the sum of the moments around any point is going to be equal to 0. Now we have to pick the point. I don't want to pick this point here, and I don't want to pick this point because they're not natural spots to pick. And also, if I would pick this point at the end, I wouldn't actually find this force. So the natural point to pick is right here. Now I want to go ahead and label these. So let's go ahead and we'll call this A, B, and C. So I'm going to say my sum of moments around point C equals 0. Okay? Before we get any further, let's go ahead and write that on here. A, B, C. All right, so my sum of moments around point C is 0. Now, I want to go ahead and look at what makes those moments up. So the first thing that I see that has an effect on it is going to be this downward force, this blue arrow. So I'm going to go ahead and put this in blue. And remember, a moment is a force times a distance. The force here is 80 pounds, and my distance is 14 inches. All right, so that's my first one. Now we want to ask ourselves, is this a positive or negative moment? And we'll remember that positive moments go counterclockwise and negative moments go clockwise. We can also use our right hand rule here. And if you're doing that, you're looking at it and our focus, our pivot point is on C. So this is going to be a counterclockwise moment, which means it's positive. So I'll go ahead and leave it positive. So that's our first one. What else can cause things to spin around point C? The next one's not quite as obvious, but our force out here at A is pushing on the bar. Even though it's just counteracting point B, it's still pushing on the bar. So we're going to count that as a force on or I guess a moment around our point C. So we don't know what that force is yet. So I'm just going to call it force at A. But I do know how far away it is. Now to do this, we have to do a little bit of math. We need to be a little bit careful here because it's easy just to say, oh, I see a number 20. It's next to A. I'm going to call it 20. But remember, we're taking our distance from point C. That's the point we're rotating around. So it was 14 to here, and then it's another 20 to A. So I'm going to call this 34. All right. Now, go back. Which direction is A going to cause it to rotate? Well, it wants to come up, so it's going to go around point C this direction. That's clockwise. So I want to come back and put a little negative sign here. So it's going to be negative force at A times 34. And this is going to equal 0. So those are the two objects that are going to create moments around point C. And remember, they're going to equal 0. Now, I'm going to do a little bit of algebra and rearranging here. Let me grab my calculator real quick. 80 times 14 is 1120. So I'll keep that blue. We'll say 1120. And then we're going to say minus, because we're adding a negative here, minus 34 times the force at A equals 0. All right. We'll do a little bit more algebra here and rearrange. We'll say 1120 equals, and we'll move the negative 34 times force at A to the other side, equals 34 times the force at A. And I can solve this by dividing both sides by 34, and I'll find that force at A is equal to 1120 divided by 34, which is 32.94. Now, if you're looking at this and you're saying, hey, you know, that's all well and good. This is 80 pounds. This is almost 33 pounds. But how do I have 80 pounds down and only 33 pounds up? The answer is because this pivot itself is actually also creating an upward force. Now, we don't actually have this figure into our moments equation because this force, remember, to find it in the moment, we have to multiply the force times the distance. The distance from this force to point C is 0. So even though it has a force, the distance is 0, and since a moment is a force times the distance, its moment is 0. However, what we can do is we say if I have 80 pounds down and roughly 33 pounds up, I know that I still need another, approximately 47 pounds here. So the pivot is pushing up with 47 pounds. This force out at A is pushing up with 33 pounds. And we know that the original weight here, the blue weight, was 80. All right, so that's our first practice problem. What I want you to do is we're going to go ahead and select it here. We're going to look at this problem. I'm going to go ahead and delete what we have. And this is going to be the first one. So we have a force 35 inches from the fulcrum, pushing down with 65 pounds. And we have another force here. And we're going to go ahead and label these. We'll call this A, B, and C. And what I want you to find is what is the force for B. All right, take a minute and go ahead and do that and fill in your answer. All right, now that you've got your answer, let's go ahead and look at our other problem. So let's look right here. In this case, instead of a lever, we have a beam that's supported on both ends. So it's supported on both A and B, And it's probably best to go ahead and we'll call this point C. All right. Now, we want to find the upward forces on A and B. You can kind of imagine this like two people carrying a couch. So you've got person A and person B. The weight of the couch is somewhere in the middle, maybe not perfectly in the middle, depending on how it's built, but both person A and B are going to have to push up on the couch some. And we want to find out how much each of them has to push up. So what is this force? And what is this force? Now to start this, I'm going to stick with the equation that we had started with. The sum of the moments around any point is going to equal 0. Now, I can pick a point. It doesn't really matter whether I use A or B. When I get all done, I'll have the same numbers either way. I'm going to go ahead and just say the sum of moments around B equals 0. Okay? Now, we're going to not color code it this time. So I'm going to take my moments around B. The first thing I see is, of course, our downward force. This downward force is going to cause it to rotate around this way, which is counterclockwise, so that's going to be positive. So my force is 500 times my distance of 9 feet. Then out here, I have a force upward on A, and it's going to rotate this way, which is clockwise, which will be negative. So I'm going to just go ahead and say minus the force on A. And a lot of times we write this force A in the y direction in case there was a horizontal part. So we'll just say force A in the y direction. We'll simplify it. We'll say force A times the distance. Now its distance, again, it's easy, just write 4, but look at the overall thing. Remember, we're basing our moments on point B. So our distance here is 13. All right, those are the only two forces that cause a rotation around point B. Now you might be again looking and seeing this force right here at B, and you're like, well, why doesn't that cause it to rotate? And remember, a moment's a force times a distance, and the distance from this force to point B is 0. That force is on point B. So since the distance is 0, the moment's 0, we're not going to worry about it. So back to our equation. These are the two forces and their distances, the 500 pounds at 9 feet and the force A at 13 feet. And the sum of those moments, according to our equation, equals 0. So 4,500 minus 13 times force A equals 0. We'll rearrange it. 4,500 equals 13 times force A. Divide both sides by 13, and we'll find force A. 4,500 divided by 13 equals, a nice round number, 346.154, etc. All right, so this is force A. All right, we'll make our lives a little bit easier. Let's just call it 346 pounds. So this is 346 pounds. So if I have 500 pounds down and 346 pounds up, how much more do we need to push up? Well, I want to introduce you to a new equation. It's not very hard. So what we'll say is the sum of the forces in the y direction equals 0. So if this object isn't moving, we know a couple of things about it. 1, it's not spinning, so our moments are equal 0. And 2, it's not flying up in the air and it's not falling down to the ground. It's still, so the forces have to be equal. So our forces vertically, our forces in the y direction have to be 0. So 500 down, 346 up, and then some other amount up here. Now when we do this, what we do is we just say that up is positive and down is negative. So what forces do we already know? We know we have 346 pounds up. We'll leave that positive. We have a negative 500 because this is pushing down. And there's a third force. We're going to count this force because we're not talking about moments anymore. So the distance, the fact that it's 0 from point B doesn't matter. We're just looking at the forces. And we don't know what this is yet, so I'm just going to call it plus force B. And you may ask, how do you know it's plus and not minus? How do you know it's positive and not negative? What if this force is actually going down? Now, I mean, common sense would tell us that, but sometimes common sense isn't enough to figure it out. What I'm going to do is I'm just going to assume it's positive. And when I get to the end of this, if I get a negative number, I'll know that I was wrong. Like if I get negative 100, I'll know that instead of going up 100, that it should actually be going down 100. All right. So these are my three forces, and I know the sum of them equals 0. So when I get here, I'm going to say 346 minus 500 is negative 154 plus force B equals 0. I'll move the 154 to the other side. So I'll say force B, add 154 to this side to cancel it out. Add 154 to that side equals 154. So we'll come down here and we'll say 154 pounds for that one. All right, so this is how I solve a beam that's held at both ends using moments. What you're going to do is solve this beam down here. Notice we have a similar thing. We're going to say that this is C, and its downward force is, let's say 800 pounds. And we'll go ahead and put a couple distances on here. We'll say that this distance is 12 feet. And over here we have a distance of 28 feet. All right. So what I want you to find in this one is go ahead, and the value we're looking for is force A. What does that equal? Now, once you get force A, we're also going to want to know what is force B. And you're going to need both of these values to answer the question that's going to pop up. All right, so take a couple minutes to do this and go ahead and type in your answers.